Fractions can be a thorn in your side unless you go back and try to get a little more comfortable with them. We will be using fractions throughout the semester, and so if at some point you've forgotten how to do them when we're solving equations or whatever, come back and review this lesson just to see how to do it one more time. You can always go back and look at section 1.3 and the beginning of the chapter in chapter 1 to look at these objectives again. So the one thing we need to remember whenever we're adding or subtracting fractions, we have to have a common denominator. So for example, 2/3 plus 5/3. If I added these two fractions, then I would get 2 plus 5 over 3, which is equal to 7/3. The idea behind adding and subtracting fractions is we have to have a same denominator so that I can just add the numerator, 2 plus 5. I can leave this answer as 7/3, or I could rewrite this answer as a mixed number, which would be 2 and 1/3. I get that by dividing 3 into 7. It goes in 2 times with a remainder of 1. I put the remainder over the denominator. Okay, so when we add or subtract fractions, we're adding and subtracting the numerators and leaving it over the same denominator. Let's practice that again. Here I have 2/3 plus 1/2. Only this time I do not have a common denominator between them, so I need to find one. This is where your multiplication facts are going to come in handy. I know that both 3 and 2 are going to divide, or I know that they are factors of 6. So 6 would be my common denominator here. I normally write my fractions when I convert right underneath, because I say to myself 3 divides into 6 2 times. 2 times 2 is 4. How many times does 2 go into 3? 2 go into 6. It goes in 3 times. So 3 times 1 is 3. Now I have same denominators, so I can just add the numerators. And I end up with 7/6. I could leave it like that, or I could rewrite it as a mixed fraction to be 1 and 1/6. Okay. Here I have 3/8, negative 3/8 minus 5/6. What is going to be my common denominator between both 8 and 6? In other words, what's the one number that both 6 and 8 will divide into? I know from my multiplication facts that they will divide into 24. If you got a bigger number that they both go into, that's going to be okay. It will still work, it just makes your numbers larger. So now I think to myself, in other words, I'm turning 3/8 into an equivalent fraction with 24 in the denominator. 8, what do I have to multiply 8 by to get 24? Well, I have to multiply 8 by 3, so I'm also going to multiply the top by 3. 3 times 3 would be -9 from my negative sign. What do I have to multiply 6 by to turn it into 24? I have to multiply 6 by 4, so I have to multiply the top by 4. 5 times 4 would be 20. And I have a negative, I'm going to bring my subtraction sign down. My denominators are the same, so now it just becomes a regular subtraction problem. Don't forget, this has got integers in it, so I'm going to change to addition and change the second sign. This means I'm going to have -9 plus -20, and I get -29 over 24. I can leave it like that, or I can change it to a mixed number, and I get -1 and 5 over 24. So let's look at what happens if I want to, let's say I'm subtracting from a whole number. I have a whole number here and a fraction here. Well, I can take 5/16 away from 7, but I can't do it without borrowing. So we need to practice that. In order to borrow, just like if I were to say, let's say I wanted to 29 minus, or no, let's change that. Let's change that to 27 minus 9. We know from borrowing and subtraction that we learned a long time ago that I can't take 9 from 7. It doesn't work that way. So we borrow from the tens place. We reduce that by 1, so now that's a 10. And we add that 10 to this place, so it became 17. That was really what we did when we borrowed. We're actually borrowing something from the tens place and moving it into the ones place. But we had to borrow a whole 10. So when we subtract this, 17 minus 9 is 8. So the answer would be 8. 27 minus 9, and then 18. Okay, so that's the concept. And we're going to do the same thing when we borrow from 7. Only this time I have to borrow from the whole number 7, and I'm going to reduce that to the whole number 6, and I'm going to write a fraction next to it. I'm going to use the denominator 16 and rewrite this as 16 over 16. Well, let's think about that for a minute. The reason this works is because if I added 6 plus 16 over 16, well, 16 over 16 is actually 1. So 6 plus 1 is 7. This is how we're changing the whole number 7 into a mixed number, so I can subtract now. So I'm really going to subtract 5/16. I bring my 6 straight down. 16 minus 5 is 11 over 16, and that's my answer. That's how you borrow using fractions. And we do use that sometimes when we solve equations. Now what do we do when we multiply fractions? Well, I can try to reduce vertically or diagonally before I ever multiply, and then when I get my final answer I can reduce. The difference between addition and subtraction and multiplication of fractions is that I'm going to multiply straight across in the numerator, 2 times 4, and I'm going to multiply the denominators, 3 times 5. Well, I end up with 8 over 15, 45. No, 15. 8 over 15, which does not reduce. So I'm done right there. I could not have canceled or reduced diagonally or vertically. But let's try that in this one. Let's say this time I'm going to multiply 2/3 times 3/10. Well, before I ever multiply, I know that 3 will go into 3, so I can reduce those. I know that this 2 will go into 10 5 times. Now when I multiply straight across, I'm left with 1/5. I could have multiplied straight across and gotten 6 over 30 and then reduced it, but this was easier. What happens if I multiply a whole number by a fraction? Well, since we want to multiply numerators and multiply denominators, I need to change this whole number into a fraction, and I do that by putting it over 1. Now I can multiply 5 times 3 to get 15, 1 times 4 to get 4. And I can leave this as 15 over 4. The concept of division really isn't any different. We're going to keep the first number, change the sign to multiplication, and flip the third, and then multiply as normal. So we're going to keep the first, change the sign, flip the second. Keep, change, flip. Now, I can't reduce anything here, so I just multiply straight across, and I get 9 over 50. And I have to leave it like that. If you were tempted back here to try to reduce, that would be wrong. You cannot do that while it's still division. We can't reduce anything until we make it multiplication first. Then I can reduce. Okay, so let's go ahead and let's practice again on this one. 7/8 divided by 28. I can't do anything unless I have to multiply and divide fractions. So I'm going to change 28 into a fraction. Now I'm going to keep the first, change the sign, flip the second to 1 over 28. Here I can reduce. 7 divides into 28 4 times. That's as much as I can do, so I end up with 1 over 32. Okay, so here is a review of how you add, subtract, multiply, and divide fractions.